first began, light has remained unchanged. Now, man has created a new kind of light with powers and properties unlike anything that existed before. Laser light.
Research as well into why certain animals, like I think lobsters don't like die of old age.
What? No.
Yeah, they don't die. I'm pretty certain it was lobsters, because they'll die of illness, or if you like, of course, if you like fry them for food, of course they're gonna die. But in terms of age, like if you give them a perfect environment where they're not bothered at all, and they don't die.
Wow, I did not know that.
Yeah. That is some, there's also like something called a hydra. They don't die. They manage to I think like continuously regenerate. That might be the wrong term, but I'm aware that they don't.
That's very interesting.
Yeah,
that's weird. I mean, honestly, sea life, they live like, I feel like it's such a different. It's obviously a different world, Thinking about squids and how they survive underneath high pressures, like if they're able to be underneath. Have you seen those colossal squids on YouTube?
Yeah, I have. I definitely have.
I mean, to think that they're like 60 meters long. I mean, that's insane. And like,
oh yeah, I think you might be talking about. There's another property called deep sea gigantism. And scientists still don't know why. It's like, why is it that the further down you go in the ocean, like why is it that animals get bigger? And there are a number of theories, but there's no like confirmed mechanism for why.
I wonder if it has anything to do with like pressure. Like if the larger your body is, the better it is to, I don't know, to like handle pressure. Like this, I don't know. I'm just assuming.
That might be part of it.
Yeah.
One of the theories is like, okay, the pressure does like, it has some kind of a contributory mechanism. But once again, I'm not. The only reason I know this is because there's a YouTube channel. I think it's called like Deep Sea Oddities.
Okay.
And they do a really awesome job showing you all the freaky stuff there is, like in the depths of the ocean.
Right, yeah, and those things always freak me out. Yeah. Okay, so the ingredients in this mRNA vaccination, for those of you that are interested in learning, is they're very simple ingredients. To me, like I guess in biology, like you hear these are things found in your kitchen, kind of. So we'll see. So you guys will be the judge of that. So the first one, obviously, okay, is it going to be found in your kitchen? It's the mRNA, which is the. Imagine just having.
There's probably like some PhD out there who's just gonna like knock on your door one day. I'm like, oh hey Ryan, I think of like one strand of COVID-19 mRNA. Oh, thank you very much. It's like you knock on your neighbor's door for a cup of flour.
Yeah. Can I borrow that half mRNA strand, about 2 teaspoons of that strand, please? Thank you very much.
Let me get some guanine and cytosine. Let me get some of those base pairs just in case.
And okay, so and this mRNA obviously is important. Again, it helps create that protein, and so the exact gene sequence that is said to be used isn't publicly available. So they said they're going to tweak it such that, because the virus is always sort of mutating, which is another extraordinary like feature of bioviruses, is their ability to adapt and to mutate. But yeah, so the next ingredient is definitely not going to be found in your kitchen. So the other ones are, though, I promise. Fake news. Fake. Just kidding. Okay. It's the lipids. And so in the Pfizer vaccine, they use lipid nanoparticles to encase this mRNA. And nanoparticles are basically a tiny greasy sphere.
Literally, you can literally call it greasy too, because lipids are kind of like the
oil,
the core component of oils, fats.
Yep.
Yeah.
And so they protect the mRNA and help it slide. It slides inside the cells. That's what I put. So it's able to sort of sneak past that the barrier, the membrane, and to go straight through. And so the size of this is around 100 nanometers across. So this is nano sized. So it's 100 nanometers across, and there's 4 different lipids that they used. One primary ingredient is the ALC0315. Now I don't know how they come up with these names, but it sounds like a robot. And so this.
You remember when I had all those astronomy articles? I was talking about how Hayabusa 2 was getting off that asteroid. What was the name? It was Ryugu, but it was like Ryugu something 90. Like the naming schemes for some of these things are ridiculous. They're absolutely nuts.
Yeah, it's like, why did you choose 0315? Is that someone's like phone number? They just slapped onto the end of that? But so what's so special about this one is that it's ionizable. So the RNA is positively charged, so this becomes negatively charged, and this allows the RNA and the lipid to stick together. So that's sort of like the sandwich, keeps it nice and tucked. And the other lipids, one which is fairly common is the molecule cholesterol. And now I remember this in AP Bio, cholesterol is on that lipid membrane that sort of acts as it keeps the structural integrity of the cell. That I know. And it also helps stop clumping. So yeah, for mRNA, the lipids, now the salts. So it's the salt is they contains 4 salts, which is wow, I almost want like 4 salts, but anyways, one which is an ordinary table salt, and together they keep the pH of the vaccine close to a person's body. So salt is super helpful in keeping that pH, I guess, within our body to help regulate that level, which is very important because in bio, pH, if you're off by a slight number, that's going to mess up your
body's going to go nuts. But also,
right.
For those in chat who may not be as chemistry inclined, when we say salt, we don't necessarily mean table salt. Like there's a whole umbrella of compounds that consist of a metal and it's like a halogen, a metal and a halogen, or no, it's an alkali. It's now I'm okay. Because I took chem for years, dude. Like I'm really blanking on what a salt is, but it combines two classes of compounds, and it's an umbrella term. So when we say salt, there's more kinds of salts than just table salt. Is what I mean to say.
Yes, sir. Yeah.
So we're not. This vaccine does not contain. Well, I don't think it contains a bunch of table salt.
From the MIT technology, this article, it said which is ordinary table salt, which is pretty interesting.
Oh wow!
So
okay.
it does use like ordinary table salt, which you can find in your kitchen. Hey, let's go. That's the first one out of the list that I said that they're all going to be from your kitchen.
mRNA, which nobody, I don't think, keeps in their
yeah.
You can't just buy a jar of mRNA.
Yeah.
Then, what was the other one? Lipids.
Mm-hmm. Lipids.
Wait, no, you have lipids in your kitchen though.
Yeah. So I guess I'm right
oils,
on that.
Soap.
Mm-hmm.
Soap, like a bar of soap. Usually when they say you can make soap out of animal fat, you're just repurposing those lipids because the hydrophobic nature makes them great for getting grime off your hands and other surfaces.
Right, and the triglyceride fatty tails. That's what I remember.
Yeah, this long hydrocarbon chain.
Right.
It's got this tail, and all our cells, right? It's a lipid bilayer, so it's like 2 layers of these lipids. But so I think when you said salt, I think salt is the second ingredient that we can find in a kitchen.
Yes, sir.
Salt and lipids.
Yep. And so the 4th ingredient is sugar. Wait, is this the 3rd one? No, this is the 4th one, right?
Right, but it's the 3rd one that you can find in your kitchen.
Yeah,
so
yeah.
Kind of staggered by one.
So it's sugar, plain old sugar. In this case, it's sucrose, and it allows the nanoparticles from sticking together and safeguarding them for when they are frozen. Because in this mRNA vaccination, it's really important that when they store it, it's stored at negative 100 degrees Fahrenheit or negative 73 degrees Celsius. So it has to be pretty cold,
The logistics for this vaccine are incredibly impressive. To be able to ship this stuff, I think I was reading from BBC News. You have these specialized refrigeration units that have to go on planes, and then once that refrigeration unit gets opened, you got to get that vaccine out as soon as possible, because every time you open and close that fridge door, the temperature fluctuates and the vaccine kind of already begins to lose its effectiveness. So, but the logistics are very impressive on a huge scale. Yeah. And
so the last thing non-ingredient, because there's that I wanted to hit, was that there's no preservatives. And what makes this different from other traditional vaccines is that, but there are no preservatives, which basically means that it doesn't. Oh, here's the thing that other traditional vaccines contain is called thimerosal. Yeah, like thimerosal. I'm butchering it. But those are all the ingredients that goes into mRNA vaccination, the mRNA vaccine, which is pretty like it sounds simple, right? I mean, from a biology standpoint, you know.
Wait, so let's recap. So look, we got mRNA. Right? We got
mRNA. Yep.
A pinch of mRNA. We got some lipids.
About to go
right?
Gordon Ramsay on us.
We got lipids. We got salts, right? And then we got what else? Sugars, right?
Sugars. Yep.
And then you said no preservatives.
No preservatives. Yep.
So I don't know. So we laughed our butts off at this one, but nobody keeps like a jar of mRNA sitting around in the kitchen. So that leaves you 3 ingredients. That's what.
Yeah.
Lipids. So you can find those in oils, animal fats, and then you have your sugars, and then you also have your salts.
Yep.
Wow. So I guess the stuff you put in your body. I mean that sounds pretty darn safe to me. That sounds pretty darn safe.
Right, and this goes sort of in the context of like, okay, well, what am I putting what does this new vaccine have? Right, the ingredients people that are scared of, but it breaks it down really nicely to the general public of what's in these vaccinations. And I didn't know I didn't know these ingredients. I thought vaccines were pretty complicated, that it needed like these certain chemicals, like these certain I don't know, like these chemical terms. Right. This sounds safer than eating, I don't know, some foods in your everyday store. When you flip that back, you see the active ingredients or the ingredients of some food.
It's scary.
Some
of that stuff is scary.
Right. Yeah. So I mean, this mRNA vaccination, I would say, I would give it the 2 thumbs up, and I think,
Once again, thank you so much to everyone for participating in chat, for listening to us and our antics, and we greatly appreciate once again our new followers, and we look forward to next Sunday when we'll have another round.
Appreciate the support, and we'll be back here next Sunday. Yeah. All right, guys. Have a good night. Bye.
Bye.